अस्सलामु अलैकुम। आई एम प्रोफेसर मोहम्मद एहसान चट्ठा। ऑर्गेनिक पॉलीमर्स का आज का लेक्चर सिंथेटिक पॉलीमर्स के बारे में है और सिंथेटिक पॉलीमर्स में फर्दर आज हम पॉलीयूरेथेन को पढ़ेंगे। पॉलीयूरेथेन्स आर पॉलीमर्स दैट आर formed by joining the diisocyanate or polyisocyanate and another monomer is diol. Student, you have noting here that compound diisocyanate is aromatic here, while second compound, the monomer that combine, is ethylene glycol. Polyurethanes are many types of many polymers that are formed by isocyanate and ethylene glycol. Their isocyanate structure varies depending upon the properties of the polyurethane. Polyurethane are the polymers which are mostly formed by the reacting polyisocyanate with polyol. Both isocyanate used to make polyurethane contain on average 2 or more functional groups per molecule. Since recent effort has been dedicated to minimize the use of isocyanate because isocyanate has severe toxicity issues, so the polyurethane without isocyanate is the advanced class of the polyurethane. These are formed to mitigate health and environmental content. Polyurethane products are often called urethanes, but this word cannot be confused with ethyl carbamate. Ethyl carbamate are also called urethane, but polyurethane neither contain nor produce any ethyl carbamate. Polyurethanes are used in manufacture of large number of flexible, very high resilience foam, seating, rigid foam insulation panel, microcellular foam seals, gasket, durable elastomers, various wheel and tire material, automotive suspension, bushing, electrical parting compound, high performance adhesive, surface coating material, surface sealant material, and various synthetic fiber, most known as spandex brand, and carpet painting, carpet plastic, and similarly various electrical or electronics instrument that is used in houses and in circuit boards will. According to some history of this compound, Otto Bayer and his co-worker I.G. Farben, Leverkusen, Germany, first made polyurethane in 1937. The new polymer has made some advantage over existing plastic and were made by polymerizing olefin I polycondensation and were not covered by patent obtained by Welleth and Carruthers and polyesters. Early work focused on the production of fiber and flexible foam, but latest in 52 polyisocyanate were become most usable multiple purpose material. It is composite material, form rigid form, gum rubber, elastomer, linear fiber, and various other. In recently, there has been made changes to make it versatile in uses and using isomer, using monomers beyond ethanol and diisocyanate. In 1956, DuPont introduced polyether polyphenol, especially polyteramethylene ether glycol and BASF, and DuPont Chemical Standard sealing polyalkylene glycol. But all these are the joint adventure, are the beginning of the new urethane chemicals. In 1960, about 45,000 metric tons of flexible polyurethanes were produced. Availability of the various blowing agent and inexpensive polyether, polyols, methylene diphenyl diisocyanate allowed polyurethane rigid form to be used high performance insulation. In 1967, urethane modified polyisocyanate form were introduced with more thermal stability and flammability resistance. In 1960, Bayer showed the plastic car in Germany. Part of these cars are their panels, rim are formed of the polyurethane. So this material become very stiff and composite and versatile use. Starting from early 1980, water-blown microcellular flexible foam mold gaskets for automotive panels and air filter sealing replace various polyvinyl chloride plastisols and various other applications. Polyurethanes now used in high temperature oil filter application too. Polyurethane foams, also known as foam rubber, is sometimes made using small amount of blowing agent to give less dense foam, better cushioning and absorption and thermal insulation. Later in early 19th and impact on the ozone depletion, the restriction of many chlorine blowing agents such as trichlorofluoromethane was changed and blowing agent was changed with the carbon dioxide. Similarly, pentane 1,1,2 tetrafluoroethane and similarly many other blowing agents are used to make the polyurethane versatile. Student, now we discuss the chemical reaction take place in formation of polyurethane. Polyurethane are the class of compound which include epoxide, unsaturated polyester, phenolic, and polyurethane are produced by reacting isocyanate containing two or more isocyanate group per molecule as structure given here. Isocyanate, biisocyanate, diisocyanate, and polyisocyanate, and similarly second reacting unit monomers as polyol. Simple polyol is ethylene glycol, which is the diol. It has the 2 hydroxy group per molecule. All these molecules are reaction in the presence of some catalyst. This will later discuss the various availability of the catalyst. Properties of the polyurethanes are greatly influenced by the type of isocyanate and polyol present in them. Long, flexible segment by the polyol give soft, elastic polymer, high amount of cross-linking, tough and rigid polymer. Long chain, low cross-linking give polymer that is very sticky. Short chain, lot of cross-linking produce hard polymer with long chain, and intermediate cross-linking give polymer useful for foam. Cross-linking present in polyurethane means the polymer consists of three-dimensional network and molecular weight is very high. In some respect, piece of polyurethane can be regarded as a giant molecule. Polyurethanes are the versatile class based on the various large variable monomers of the diisocyanate, polyisocyanate, and polyol. Isocyanate are very reactive material. This makes the polymers require special care in handling. The aromatic isocyanate, especially diphenyl methane isocyanate, as given here the structure, or toluene diisocyanate, are more reactive than the common aliphatic diisocyanate. Similarly, such as hexamethylene diisocyanate and iso 4-diisocyanate, most of the isocyanate are difunctional, that are exactly 2 isocyanate group per molecule are present or more than 2. Polyols are the polymers in their own right have average 2 or more hydroxyl group per molecule. Polyethers polyols are mostly by copolymerizing ethylene epoxide and ethylene oxide with suitable polyol precursor. These grades are polyol formed have many types of polyurethanes, from the low to high weight polyurethane with low cross-linking to high cross-linking with different properties. Here is the tertiary amine which catalyze the isocyanate to form the polyurethane. Generally, generalized reaction of isocyanate is given here simply a isocyanate link with diol. The exact mechanism will be we already studied the exact mechanism. Isocyanate link with simply diol OH and resonance stabilization take place, and carbonyl group bond shifted toward the carbonyl. Student, you know the carbon of diisocyanate is attached with one nitrogen atom and one oxygen atom. One nitrogen atom and oxygen atom both are most electronegative atom, hence they withdraw electron from the carbon, and carbon is very electron deficient in isocyanate. So the lone pair of the oxygen of the glycol OH group will attack on carbon of isocyanate, and resonance stabilization, the hydrogen will have after resonance stabilization were have attracted by the lone pair present on nitrogen of isocyanate. So hence this function group regenerated again in main structure of polyurethane. This is the generalized mechanism of polyurethanes which is formed here. Reaction of the polyurethanes are various class here are given. Another reaction in which water take part in first step, in which in first step isocyanate alkoxy group will be attached. In second step this is replaced by and others have diisocyanate group. So there is another mechanism of formation of polyurethane. The mostly discuss the raw material. Raw material is isocyanate to use to make polyurethane, which have the one at least two isocyanate group, and mostly aromatic isocyanate are preferred. Here isocyanate, diphenyl isocyanate and toluene diisocyanate are mostly taken. Both are less expensive and much reactive as compared to other isocyanate. On an industrial scale, we use both toluene diisocyanate and methylene diphenyl isocyanate in our polyurethane product. Here is the structure of again given the isocyanate. Now one monomers 4 position, and another there is 2 and 4 position, and third one is 2 position, but all these led to common structure here mentioned in green color polymers methyl diisocyanate urethane. These are the monomers 4 2 and 2 methyl diisocyanate. Aliphatic and cycloaliphatic isocyanate are used in small volume, mainly material of the polyurethane, where we required the coating, color, transparency. Some are important these cases for the formation of polyurethane, but in major we less expensive diisocyanate and diphenyl isocyanate or toluene diphenyl isocyanate we utilize in formation of polyurethane. While student polyols are mostly of the ethylene glycol, but we change the ethylene glycol with others many difunctional compound such as epoxide with active hydrogen containing starter material, and polyester polyol also used by the condensation of dicarboxylic and hydroxyl. These are further classified according to their use and molecular weight. More flexible polyurethane with low molecular weight and polyol make them more rigid. Student, polyol are considered for their property, for their flexibility, for their low functional initiators as propylene glycol, glycerine, sorbitol, water solution, polyol for rigid application in high functional initiator as sucrose, sorbitol, toluene diamine, Manch bases, propylene oxide, ethylene oxide. These are initiators utilized in polymerization. Polyurethanes have wide range of impact and utilization, and various class are have formed which are different types of weight cross linking. Student, here we study the some types of catalysts, mainly they catalyze the reaction of the polyurethane. We categorize the catalysts in two categories. Number one is the amine compound and metal complexes. Amine catalysts have tertiary amines are mostly triethyl diamine. Similarly, dimethyl cyclohexylamine, dimethyl ethanolamine, these are taken. Tertiary amine catalysts are selected based on the whether we drive urethane polyisocyanate or its property gel like or various others. Metallic compounds mostly utilized here are mercury, lead, tin, bismuth, zinc used as a catalyst. Mercury carboxylate are particularly effective catalyst for the elastomer polyurethane coating sealant application, while selective polyisocyanate reaction. But you know, polyisocyanate are very toxic. Bismuth and zinc carboxylate have been utilized alternatively in case of mercury. Although mercury is toxic, but can be utilized. If we want to replace the mercury, then we use the bismuth and zinc carboxylate alternatively. Surfactant use in polyurethane. Surfactant are those material which make the monomers to attach with each other, wetting them, increase their reaction miscibility, stability, and cell structure formation to form any subsurface voids. तो many जो surfactant है utilize here that eliminate various defects that are latest found in foams and other elastomers forming and material. Basically, surfactant are wetting agent that are used to eliminate surface defect in polyurethane. Surfactants are utilized to minimize the surface effect and increase the wetting effect. Health hazard issue and safety. Fully reacted polyurethane are chemically inert. No exposure limit are established still now, but there is still liquid resin blended isocyanate may have many You have hazards and many health issues that on skin, respiratory issues. Additionally, we utilize amine glycol phosphate spray to mitigate the risk. All these about the polyurethane, its various raw material, its reaction chemistry. Later, we study the polyurethane on the base of its uses. Polyurethane based on the uses. Hopefully, student, you will learn betterly understand the polyurethane, the compound of carbamate, yani link diisocyanate with polyols. But latterly, as I have already explained, we replace diisocyanate with other compound to form other advanced polyurethane to minimize the health issue link with iso and diisocyanate. Thank you, Allah Hafiz. Give your queries, questions, and any other things about the polyurethane history, chemistry, simple about the raw material and general action. Thank you.